Good afternoon. Thanks for joining the Innovate Ag Smart Orchard webinar series. I'm Steve Mansell and be your host today. So glad that you could be here with us. Our focus today is on rural connectivity, emerging options for farms. And I'm joined by Andrew Nelson with Nelson Wheat, Scott Waller with Thingy IoT, and Todd Brandenburg with Pocket INET. And I'll get into sharing a little bit more on each of them here in a moment. A quick background on Innovate Ag. Our focus really is working with growers to unlock value through new data-driven insights. And what we hear over and over from growers is you've got many different apps that you're looking at to make your decisions, whether that be related to labor, chemical, yield, sales, and our focus is simplifying that, bringing that to one centralized data warehouse, and then helping visualize that so that you can make decisions more easily. Our focus is predominantly on permanent crops, apples, nuts, grapes, and we're happy and proud to work with WSU and OSU and other land grant universities for a tight feedback loop. But let's get in a little bit to meeting the panelists. So again, Scott Waller, CEO and co-founder of Thingy IoT, great background at Cisco, and really excited that he's increasingly working in the ag space, and he'll share a little bit more on his background, including some avalanche control work and related monitoring work that he does, which is quite appropriate given it's currently snowing in eastern Washington. Andrew Nelson is joining us from the metropolis of Farmington, Washington, and his background is quite unique in that he has computer science and business degrees and also farms 8,500 acres of dryland. So he'll be sharing some unique perspectives today. And then Todd Brandenburg is president and CEO of Pocket INET. Great background there. In fact, we're broadcasting over fiber to the home from my home today over the Pocket INET network. But they have a great footprint across eastern Washington and are really pushing the envelope with some new leading edge wireless technologies, which you'll hear more from Todd on today. So I wanted to start with a quick background on a hackathon that we did last year with Microsoft, focused on connecting farmers and drones, and just give a little bit of a background there for a starting point.
For growers, they really need rural connectivity, and 60-some-odd% of farms actually struggle with having limited or no connectivity in the first place. So it's very hard for them to communicate outside of using CB radios and kind of spotty cell coverage where they can call and text each other.
Connectivity is a huge issue for us. Out here in rural America, it's difficult to get access to high-speed connectivity. So our data sensors often lapse out. We can't get them connected to Wi-Fi or to even cellular networks at times. So we're switching carriers and doing all kinds of things to try and get connectivity. So very important to us. New equipment's coming. It's got sensor-based packages. We're trying to optimize fruit quality and yield, and all of those things require better data to make better management decisions.
Innovate Ag as a smart orchard. And so we're working with a grower in just north of Tri-Cities or Pasco, Washington. These are two 20-acre lots that you can see here at the top. And these are some of the sensors that we have deployed across these 20-acre lots. And they vary from weather stations, different brands of weather stations, to soil moisture sensors, to irrigation sensors. The grower can't really look at all this data, the sensor data, unless they actually have connectivity on their cell phone.
We're just focused on being a data hub. And we do use FarmBeats as a core component, not the only component, but as a core component of ingesting data in from some of the different sensor providers.
It can be added in the base station to amplify the signal. and also cover much more protocols. And you have the ability to do that over slicing on the 5G. So you can offer a slice for IoT, offer a slice for heavy broadband devices that has eSIM or SIM embedded, and also have another one for Wi-Fi or other spectrum as well.
How can we work with growers to help them through imaging and through sensor data ultimately use less water?
We're an emerging industry with lots of technology coming our way, and we need platforms like Azure and other places or other platforms that will help us to utilize data better, get rid of these data silos. Data silos make it really hard to make good decisions when you have 8 different data sets given to you and none of them are stackable or layerable. So it's a difficult thing. So we would love to engage Microsoft right here in their backyard of Washington State.
So backdrop there really is that the big companies are really, Microsoft, Intel, and others are really getting increasingly interested on solving for some of the rural broadband challenges. Not much on this slide other than just kind of a backdrop is connected farms, lots of opportunity and needs there. Increasingly, growers are looking for tracking equipment, was just meeting with a farmer that said, boy, just for two farmers actually today that said just for irrigation management alone, cellular connectivity, particularly in some areas where it's really spotty, it's pretty darn critical. And so with that, I'll tee it up to Andrew Nelson. Hi, Todd. To go ahead and share. Welcome, Andrew.
Thanks, Steve. So let me try to be able to advance past this slide, if it helps. Okay, there we go. So I'm Andrew Nelson. I am a farmer in the Palouse area, dryland, wheat, lentil, peas, garbanzo beans, barley, canola farmer. And I am also an active software engineer. So connectivity to me in the field is very, very important. I'm lucky to get to work with Microsoft. I work with them on FarmBeats in my farm, proving out kind of what we do in research. And so the connectivity, especially with the amount of data that I'm generating for research, is even more important for me. I really need to be able to get data from my farm up to the researchers, and that's much more difficult than it would be if I were in a big city. As you can see, there's not a cell tower in sight in this picture. And that kind of explains why my cell coverage is absolutely terrible in my neck of the woods. I actually have 2 SIM cards in my phone, so I can switch between 2 cellular providers to attempt to get about 75% coverage on my fields on a good day. And then even when I do have coverage, sometimes the data is so slow on it, I can't do anything. So it does make it pretty difficult. I just want to step through how I have everything connected up on my farm, because you can kind of look at it and use it as a way to say, oh, on my farm, I could implement this one part, and that would make a big difference. So how we built this up is in my home office, I have something called an intelligent edge. I'm kind of starting from the bottom, but I think it makes more sense. So I have an intelligent edge, which is just a computer that will do some processing on it before sending information up to the cloud. And so I can send less data up, and I can also slowly send it up to the cloud because I already have the process data on my computer in my office, so I can immediately access it. With my low bandwidth that I have on my farm, that helps immensely. Being able to stitch drone images, being able to process that information, be able to see it without actually having to send it all the way to the cloud and then re-download to see, the stitched image. I also have a LoRa sub-edge on my in my office, which connects up some of my stations I have near my house, some of the weather stations. And then I also have all my drone image storage, which goes into that intelligent edge, gets backed up there and in the cloud. Oh, it's going backwards on me. Just a second. There we go. At my farm, I have my shop connected up to my home office with just an Ethernet cable. And then on top of my shop, I have a wideband TV white space connection. So that wideband will share my internet with a shed that's about 3 miles away, non-line of sight. It would be a big pain to get a line of sight communication to it. So that way I have my higher speed internet that I have at my home office over at this other field 3 miles away at the shed, where I can do the same sorts of things. I can take my drone images and download them to my home office. I have a LoRa sub-edge there too to connect up to some other weather sensors nearby that shed. And then another thing that I'm able to do at that shed is it's on a little bit of a higher hill. So I have my IoT TV white space tower there. So the difference between the TV white space from my shop to my shed, that one's a wideband, so it takes up more spectrum. The one at the shed is a narrow band, so it takes up less spectrum. It has very slow data rates, but for my sensors that are placed throughout my fields, that doesn't really matter. Sensors don't take that much data usage. And so I'm able to scatter those sensors, 10, I've done some 13 miles away, all the way around my farm, utilizing that IoT TV white space. The nice part of it is it's very low bandwidth. In my area, we don't have a lot of LoRaWAN stations set up where I could connect to. So for me, this works out well for my farm. And then, some other people have their shop connected to another shop or shed with line of sight communication. It's just trying to get the communications where you need it. It's kind of the way that I always try to work my tech solutions. The hardest part with me with the cell phone is, for example, John Deere Operations Center, I can't download my harvest data automatically to it because the cell coverage is so spotty, it never downloads. And so, some of those things, hopefully, in the coming years, I can start utilizing, hopefully, some of these technologies that we're going to be talking about later for being able to connect, my tractors and stuff to the internet with a wider, better bandwidth connection. So with my IoT placement, I was able to scatter it among my fields, somewhat evenly distributed. I was able to see what the different microclimates were doing that year, because that is a pretty big difference. From year to year, I can have fields that get 1 to 2 inches different rainfall, especially in the summer. And sometimes those are very important rainfalls. Sometimes for my crops, I want to be, doing fertilizer. I need to do fungicide because there is more humidity. There's more risk of disease. Or if it's a little bit drier year, but they do get the moisture, hey, I can add some fertilizer, hopefully eke out a little more yield. And this really helps me figure that out, because even though I do drive around to all my fields, it's hard to hit every single field after every single little storm. I mean, if I did that with every field after every storm, I would never get out of my pickup. And that's where this makes it much easier to manage my farm. I'm able to see the conditions at the fields, without having to drive to every place. And I can also see it immediately after the storm comes through, and I can know, what the conditions were like It also helps me, figure out operations in terms of what our wind's doing for applying crop protection. And it also helps me figure out what the humidity is like for harvest time. So for us, we need it to be dry during harvest. I can check humidity, especially after rain, and be able to see if I need to start moving my equipment to a different field that's going to be ready much earlier and dry out so I can go. So last year I did that. And the year before I did that a lot because we got a lot of rain that year during harvest. And I was constantly moving my equipment around just to get, if I could get 2 more hours of harvesting in, that was a very big impact on my farm. And that's, this connectivity across the farm is really what made that more possible for me, because otherwise you spend 4 hours driving between all of your fields and you've lost all that time that you could have gained. So that's all I have. I'll go to Scott.
Okay, everyone hear me? Hey, well, thanks for the invite, Steve. Let's see, make sure I can request a remote control. Let me do that. I should be able to advance here. As Steve mentioned, background in telecommunications, and 2017, a partner of mine at Cisco and I, we built a sensor for the EPA. It was a technology challenge to really try to reduce the cost of a specific scientific sensor around air quality, but the use case was for wildfire detection. And as a part of that, we got really close to the research community, to the Forest Service and others. One of the things we realized is there's sensor technology out there, and how do we package it together? And then how do we work with the organizations, whether it's environmental monitoring or weather detection, and bring the cost of these sensor technologies down? When you look at just weather itself, there's weather stations out there that people will invest $10,000-$15,000 in these weather stations. There's no point in doing that when technology advanced 10-15 years forward to now. We've got this ultra compact, ultra efficient computing that we can do these weather stations at a lower cost. But then also, how can we solve the connectivity problem and make it as low power as possible and really just disconnect the wires? So when I left Cisco in 2019, it was all around what's out there from a sensor technology and who's innovating the fastest. And to be honest, when you look at something like LoRaWAN, we've become an integrator here in the United States and partnered with some really great companies. But a lot of the sensor technology is being built over in Europe. Andrew mentioned that there is really not much LoRaWAN coverage around yet. It's growing as an integrator. It's growing, and it's growing really fast in the United States. But in Europe, you have KPN and Orange and Swisscom, and the carriers are actually building LoRaWAN networks, and we'll get into that and what it is in a sec. But with that, it was driving a set of innovation in the sensors. So think of water flow meters, water valves, soil moisture sensors that aren't thousands of dollars, but they're $100 or less. Temperature sensors, in canopy type of weather sensors, that was being developed rapidly in Europe. So you're going to get a lot, from Swiss manufacturers, a ton of the stuff in the Netherlands. They have a ton of growth in sensor technology inside of vertical farming in the Netherlands. So with that, I wanted to become an integrator and bring that into the US because we see people are demanding these new type of sensor technology. So we're an integrator. We do all things LoRaWAN. We partner with all the greatest from the gateway manufacturers to the backend providers. And in the end, it's getting the right sensor at the right cost and getting that data in a useful place like the cloud or at the edge. But then we also custom build some stuff and consult. So what is LoRaWAN? And Andrew touched on a bunch of different technologies, but I think we all agree that the connectivity is not ubiquitous anywhere you go. You can go to one farm and you'll be lucky if you have 0G out there. Wi-Fi is not really conducive to farming and long distances. We know there's some proprietary mesh technologies. We've had Zigbee over the years and all these other technologies. But what we're starting to see is within this low power WAN space, and when I call low power, I mean really, really low power. These things are sipping battery power over 5-10 years. So we have, let's say, water valves, we have water sensors, temperature sensors that can run on a C or D cell battery for 10 years, but just transmit small amounts of data. And what this is done by is in the unlicensed spectrum, or the ISM band at 900 megahertz, you can run this very small protocol and modulation scheme called LoRa. It's intellectual property from Semtech. There's now an alliance over the last couple of years they've established that creates really what I call is this open ecosystem. And what it's enabled is long range, low power connectivity. We're not talking streaming of drone image data. We're not talking about, computer vision or machine vision running up and down the aisles with an ATV. We're talking really small amounts of data. And it's really optimized in a way that all these sensors in this ecosystem that I showed that we're partnering with, it allows you to jump on this network. There's sensors available, but also there's little transceiver devices or adaptable devices that I can say, you know what, you have a temperature sensor, a leaf wetness sensor that does, let's say, SDI 12 from maybe the meter group. I can adapt it to this technology in this open spectrum and be able to transmit at a very, very long distance. And then another tenet, obviously, in IoT is it being secure and two-way, and I'll go into that in a sec. So really, what are the benefits of LoRaWAN versus some of the other technologies? And it's not that this solves all the problem or 5G solves all the problem or Wi-Fi. It just depends. You saw Andrew's use case. He's using a combination of everything to get through line of sight challenges to lack of cellular connectivity from a provider. So one of the things, if you look on the far left, we look at power. Yes, the radios on more of the cellular side require more power to transmit small or large amounts of data. However, LoRaWAN's on that far spectrum of, like I said, if you want a sensor that is transmitting maybe once an hour over 5 or 10 years, if you think about the overall cost of that sensor, it's not just about the sensor itself, but also the power for that radio. Your battery capacity and the type of battery you need is less expensive. The operational costs of sending someone out to a field to change a sensor, you don't have to do it every season. You change it every 5th season or every 10th season. So the overall cost, or you don't need solar panels. So the overall cost of that sensor is actually lower. Now, again, it's very limited in what you can transmit. We're talking bits of data over a period of time. But one of the beautiful parts is it's also long range. And so like Andrew had shown up there, being able to get line of sight, we're able to now with LoRaWAN transmit hundreds of kilometers. I think the world record is 820 some kilometers, actually. It was done via ground to a weather balloon. I have sensors here in my shop outside that are transmitting to a satellite 500 kilometers up above. So it's possible, but again, small amounts of data. So just quickly, the architecture is you have a set of LoRaWAN capable sensors that you put out into the field. We have weather stations, different individual sensors, water control, water monitoring, et cetera, leak detection, even asset tracking with GPS devices. It transmits to a gateway. So we have a large Tectelic gateway right here, put it high on top of a hill or on top of a tower, and we can transmit dozens or hundreds of kilometers if we want. But we need backhaul, so we do need local connectivity, and whether that's Todd's local connectivity that he can provide, Ethernet or broadband-based service or a wideband-based service, or even 5G or CBRS, we can do that. Because in the end, what we want to do is connect this off to a cloud-type service. So it's a pretty simple architecture, and it's pretty simple to deploy. So the requirement is you have to have a LoRaWAN network nearby. And so if a carrier is not building it, it's pretty easy to say for a couple $100, you can actually put a small little device connected to your broadband network on your shed, and you can connect a bunch of sensors. I think as Andrew was saying, some of those weather stations. And then, the other part is you need the sensors, and you need a back-end type service. That could be in the cloud, that could be on-prem. But I think one of the challenges, it's not ubiquitous anywhere. You kind of have to build it, or a carrier has to build it for you, or a provider like us, because it's not ubiquitous everywhere. But I'll tell you, it's growing. And you have to think about the use case. We're dealing with bits, not bytes. We're not dealing with images and streaming video and audio. We're really talking about, I need this temperature of this sensor. I need this leaf wetness value. I need this ET. That's all I need. And I need it once an hour. And I need it consistent. And then I think to tie it all back into the research side, we've done a ton of work with EPA, Forest Service. We're working with the Wine Commission and others, along with the universities, on things like additional chemical measurements or air quality measurements, and how do they affect things like wine grapes, because smoke and wine grapes equals smoke taint, and that's not a good thing. And so we're going to continue innovating there and participating in the research community. Now it's Todd.
Thank you, Scott. Good afternoon. I just wanted to say that my name is Todd Brandenburg. We're from a company called Pocket iNet Communications. We're a regional service provider in the state of Washington, and we also dip into Northern Oregon as well. And our company is a little bit over 20 years old. We've been serving the region, and we do connectivity solutions, not only for internet, but for entities that need to extend that fiber infrastructure out into different areas. And we have a lot of different technologies in order to do that. So as my dad, and by the way, I grew up on a family farm in North Dakota, 500-acre farm, small farm. It was a great experience. And my dad always said that you have to have different tools in your tool bag to be able to do the right thing. And I think technology, and when it comes to internet connectivity or connectivity in itself, you just have to use the right tool, because there are many tools to be able to get the job done. I'm going to start with a video here to kind of talk through the CBRS, and I'll talk a little bit more about what that is after the video.
This day and age, it's not based on the internet.
Having a reliable network is imperative, but we're in a unique location, so it's very hard to get good service.
Most of the things that we care about and the people that we love, we're in touch with them through some type of digital media. But you can only do that if you have access to the internet. And we think CBRS is one very important way of delivering improved and cheaper internet access.
My name is Jason Guzzo, and I'm General Manager of Hudson Valley Wireless. A lot of the communities that we serve don't have access to the current infrastructure, and it's important for us to bring these rural communities online so they're able to participate in the global economy.
My name is Bruce Sundman. I'm one of the founding partners of Megabits. We're a wireless internet service provider here at Put-in-Bay, Ohio. We're on an island, and so there's many tourists that come up. There's 750 residents that are here year-round, and there's 750,000 people that visit. When the island fills up on a weekend, most of the services begin to fail. Cellular phones actually don't work. The internet slows down. Businesses even had difficulty clearing credit cards, and people had difficulty making phone calls.
I'm Matt Larson. I'm the CEO of VistaBeam, and we are a fixed wireless operation delivering broadband in some very rural areas of Wyoming, Nebraska, and Colorado. When you can't connect up with people, it can be very isolating. And rural people really need to have the same ability to connect that anybody else does.
If we didn't have internet connection, our kids would have limited access to school projects, research, and gaming.
High quality luxury anymore, it's a necessity. And WISPs are the front lines of delivering access. They're all very passionate about the communities that they operate in, and we're hoping to help supercharge their deployments. Google has really been about the development of an ecosystem to make sure that CBRS thrives. We provide a spectrum access system that allows you to coordinate the spectrum among the different tiers of users. We also provide a network planning tool that brings the highest end tools and the highest end geodata in a form that anyone can use. And finally, CPI training that's available online. That's easy to take from your home or from your office to get in-person training.
Google understands the fixed wireless community, not only by the use of their mapping software, but also their cost models are very affordable and allows us to scale.
CBRS is going to unleash a torrent of competition. We've had areas where we couldn't get to because of either spectrum restrictions or tree cover, and now those areas are wide open.
We can beam overhead and we're able to connect users at a much more affordable rate.
CBRS and the new technologies have enabled us to enter a market that previously it would have been unaffordable for small companies like ours.
Ultimately, the people who are going to benefit are the end users. They're going to have access to lower cost, more reliable internet, and the most important thing is that there's going to be a choice.
Okay, so that was a little Google advertisement there as well, but CBRS, by the way, is Citizens Broadband Radio Service, and it's one of the licensed bands that our company, Pocket iNet, had been looking at for some very long time. So we are a wireless internet service provider. We also do a lot of fiber optics to the business and to the homes. And it's about connectivity, right? Well, CBRS is one of those tools that we hope to utilize because we actually purchased some spectrum throughout the Washington State region and Oregon, I might add. But when we break this down about the network connectivity requirement, you know, there are a lot of different possibilities on how to bring that to the farm. And you know, like I mentioned, I grew up in North Dakota, and interesting enough, it's one of the most fibered states in the union, which actually have fiber to most farms throughout the state. Not so much in the state of Washington, and so we have to depend on the cellular networks, whether it's 4G or the upcoming 5G, you know, and whether or not that connectivity is actually going to get to those farms, to those fields. Well, basically, as Andrew pointed out. And so the question is, how do we bring that connectivity? Well, we could depend on the cellular network, or we could also do what's called a private network, a private LTE, if you will, type of network. And so this is just a diagram here that is talking about the internet, and then the blue lines are fiber, and then the yellow lines are what we call microwave. And that is about getting that high speed connectivity, several, you know, hundreds of megabits to the farm. And then, you know, introducing some very efficient, you know, sensor networks like LoRaWAN that Scott talked about to actually get out to the sensors. So the application, there's lots of different applications. Let me go to my next slide and we'll talk through that here too. And there we go. Well, first off, why a private LTE wireless network? Well, when you compare it to the cell network, a private LTE network is just that. The privacy is there. It's not being shared with other users. You can dedicate it for that purpose. It's very flexible, very high performance network. And you might say, well, what about Wi-Fi? Wouldn't Wi-Fi in the field work? Well, you could build a Wi-Fi network, but it's not built, Wi-Fi is built as an indoor standard, not an outdoor standard. So the handoff from station to station is just doesn't work that well. And that's where a LTE type network, a private based network, is able to hand off as you roam throughout the network. So I won't get into the technical details that much here, but I wanted to go to the use cases, possible use cases. So let's just say that you have, you've got in-field tractors, and you've got sprayers and that type of thing, and maybe you're interested in the LiDAR-based imaging, and you're downloading all these gigabytes of and sometimes terabytes of data, and you need to upload that to the cloud to be processed. Well, if you're going to depend on a traditional cellular network, it's going to take a very long time. Your connection is going to vary as you're in the field. But one of the possibilities would be to create a kind of a drive-up Wi-Fi to that shed where you have high connectivity services, you know, with a microwave, high-speed, wide-band connection, and then upload that data set very quickly, and then go out into the field again to capture more data. That drive-up Wi-Fi is a very interesting approach, but you also may have other wideband devices such as cameras in the field that are doing live HD, you know, 4K, up to 4K video. You need something that is much more capable, and CBRS is a tool to be able to have that. It's not a lot of the work right now is in fixed, but mobility is coming down the road as well for mobile operations. So, but those sensors that you have in the field for the weather stations, that type of thing, very low bit rate. LoRa WAN would be an ideal application, but it should connect, you know, back to a broadband network so that can be uploaded into the Azure cloud. So, and I just have a couple slides here. What's so special about CBRS? Well, it is well, let me just say it this way. It gives you a very long range potential network. So if you're planning to do a private network and make the investment in that direction, and let's say that you need something that's very high quality, does not depend on unlicensed spectrum. It has the power to penetrate even into non-line of sight, or what we call near line of sight as well. If you have trees in the way, a lot of these technologies require line of sight. This one does some near line of sight and non-line of sight capability, which is just wonderful. Reducing your interference is, there's what we call PAL licenses, or priority access licenses, and those are the licenses that Pocket INET has just purchased in a number of counties here in the state. How much capability? Well, it's capable of 100 megabits plus, and that would push a lot of data around that network. One of the things that I just want to say, I watched a presentation at CES about Caterpillar, and to see what they're doing with autonomous vehicles. You know, it's going to come to the farm too someday, and you're going to need a very high quality, high broadband network, you know, to be able to do those autonomous vehicles, because you can't have the network go down and that tractor go cruising on down the field, you know, and skipping around. So there are options as compared to you know, a public cellular network, and we're here and glad to talk with you about what those options could be. So with that, I'm going to hand it back to Steve. Thank you.
Thank you, Todd. I appreciate it. And do hang on for the Q&A at the end, the discussion. We'd love you to interact and ask, because there's plenty of questions and discussion around us. So wanted to close on a couple of things. One is just really our capabilities today from Innovate Ag. You saw a slide earlier on the Smart Orchard project, which we're expanding out to a second location this year. Our focus ultimately is pulling together those data sources from many places and consolidating it. Earlier point, in the bottom left-hand corner, there are some high data rate applications that can be really helpful for a grower. This particular view you see down the bottom left-hand corner is using an ATV that's going up and down orchard or vineyard rows at 25 miles an hour. And you can effectively image each and every apple and the variation between the density, the height, and the area of each tree. And as you can see, it basically looks like a Google map, and then you can zoom in and use what I'd kind of equate to something like Street View, where you can click right on in and look at where machine learning has identified each and every apple. And believe it or not, you can do this for grapes as well, as small as they are. And we can do this through the whole phenological stage from bud to bloom, all the way through to apples. Really helpful for growers in that they can use this to better understand where they distribute labor across different blocks, as well as where they may lean a little harder on thinning or for planning on harvest later on in the year. So I wanted to close with a video that summarizes the 5G Open Innovation Lab project that we announced last week. And there's a number of different folk in here from Intel, from T-Mobile, from Microsoft, that really brought this together to land a 5G test bed in Snohomish County using various different types of wireless technologies. And we're working toward bringing the same thing to Eastern Washington over time. So have a listen.
To be a farmer and make it, you got to be innovative in order to survive in this industry. You're very dependent on the weather. You're very dependent on what Mother Nature wants to bring you.
They kind of said, if you dream it, we can make it happen. So I'm like, well, I got all kinds of dreams, so let's see what we can do.
If we lose these farms, we lose our food security. Every time a piece of land goes out of production, it's heartbreaking because we can never replace that land. That land becomes a subdivision. It becomes a strip mall. And to keep these farms here, they have to be economically viable.
The commercial side of rural America doesn't have that access to the data and the applications and the infrastructure that could help them become a lot more efficient. The stuff we take for granted is not something that these farmers get to enjoy because in many cases, they're just precluded from access to the internet.
What we hope to do here is democratize that technology for farmers.
Getting to a point where they can use data to inform a more efficient approach will enable them to be more competitive and ultimately enable them to set up the farm so that they can pass it on to the next generation.
Technology can be really exciting, but it's only as valuable as the outcomes, right, that we can help drive for the communities that are leveraging this technology.
Whether it's a small boutique farm or it's a large commercial farm or somewhere in between. This project provides the information that they need to be economically viable.
So the vision behind what we're doing here is to try to bring together entrepreneurs, industry partners, public and private institutions, and really bring the expertise to solve real world problems. One of the things that we have to do as part of that is to bring growers and farmers who actually are living this every day and have the real problems and start working with technology companies so that you can build solutions that are actually meaningful and will deliver value.
In order for the American farmer to survive, we have to improve our efficiencies in our operations. We have to figure out a way to produce more food on less acres.
Nature is complex, it's dynamic, it's different every day. There is no industry comparable to farming in terms of the potential volume and effective use of data. But there's also no industry that has been further disconnected from data than farming. We're here to open the door.
Snohomish County is a county of about 850,000 people. We're the next county north of Seattle and King County. We're an extremely diverse county in terms of geographies and industries, businesses, and people.
Every industry is important, but I can't think of one that's more important than agriculture. It's our sustainability. It's one of the industries that has not seen as much innovation from a data perspective. And for smaller farmers and for larger farmers, just that access today will have a meaningful impact to their bottom line.
Doing it at a real farm is going to give us an actual set of conditions to test this technology out at and make sure when it does go to market at this scale, we've tested it in a real environment, not just simply in someone's backyard.
You look at the brands behind it. They're industry-leading, really powerful brands that, if they wanted to, could probably try and say, hey, we're going to solve this problem themselves. But actually, they've said, actually, if we work together, we solve the problem faster and we solve the problem in a better way. So that's pretty monumental.
What you're seeing is that combination of big companies and small startups. The big companies have the ability to bring those platforms, to bring capabilities, tools, foundations for innovation. Those are things that many startups don't have. They don't have access to big licenses or platforms or hardware or bandwidth or antennas. 5G Oil is really bringing those capabilities to startups.
At T-Mobile, we are building a 5G network that'll reach all Americans. But we also know this is something that is much bigger than ourselves, and that's why we're excited to be part of the Food Resiliency Project.
It's all about taking the tribal knowledge of the farmer and the technology people. You have to find ways to integrate and communicate, building tools and systems to help people who are doing God's work to get this done, really just making it happen.
These technologies are going to power things like smart farms, smart hospitals, smart cars, smart factories. So Microsoft is a big believer in those technologies. But we also know that there's a lot of work to be done, and the best way to do that is to get out on the farm, so to speak, and do some real-life test cases. To survive, farms need to be efficient, and that means they need access to the latest technology, including, connected solutions.
When we talk about farm to table, this is really technology to farm to table. You really complete the circle. We're about health, and we're about food scarcity. When we started at this 5G Open Innovation Lab, we have this notion that it takes a village. It's really an entire chain that comes together. This is probably the best way that we can give back to the society.
When you look at 5G together with edge computing, these are building blocks that other industries are using. A lot of what we're learning here as far as building a infrastructure, a platform for use case delivery. And those use cases are going to be across a spectrum of verticals. Whatever we learn here is definitely going to be able to be applied across other industries.
We're out in a real county with real farms, building real networks and starting to run real use cases. And I think that's the really exciting thing. This is not just a lab exercise. This is, let's get out there, let's just make this work.
At the end of the day, it's the good that we do with technology, and the 5G Open Innovation Lab is that venue.
The potential of having technology on your farm and learning from that technology is going to be a huge plus for us.
Your farmers are the most innovative people you will ever meet. If something's broken, they will figure out how to fix it. And that's really not any different than the technology world. They see a problem and they fix a problem. So it's going to be really exciting to see how these two worlds marry and the respect that we know they're going to have for each other and what they do. It's a very exciting time for agriculture and for technology.
Okay, great. Hopefully that provided a little bit of perspective on some of the work that's going on in Western Washington. Again, we thought we would lean in on test beds over on that side of the state with, in fact, already we've brought a number of different executives over to Eastern Washington to start engaging around that. And certainly great to have both Todd and Scott in the mix on that as well, and I'm sure Andrew over time. So just a quick housekeeping as we switch to Q&A. If you have any Q&A, please do pop them into the Q&A live section there, and we'll start reading them off and having some discussion around that. We have a number of different webinar archives available on our website. would strongly recommend in a couple of weeks, we're going to have an ag tech meetup, virtual, online. And so that'll be 2 weeks from today, same time, same place. And it's more of an open forum. So there'll be no kind of webinar, people speaking at you. It'll be more conversational and some joking around, and we'll mute out people that joke too much. No, I'm joking. But we're looking forward to that. So please do join us for that. So let's switch to Q&A. So we had a question from Mike. Yeah, we haven't dug into this too much yet around Starlink. What is the potential for Starlink in central and eastern Washington? Wow, I'll lightly touch that, and then the whole panel, I'd love you guys to do that. I mean, one, I'm excited about it. I have been kind of futzing around trying to get a Starlink invite and finally managed to have that happen, and had the box delivered to me last weekend. But the guy that actually beat me to getting it installed is Todd. So Todd, what do you have to share around Starlink and what your thinking is on the potential for Starlink?
Well, I was talking to Elon the other day. Not really, but
talking about spaceships, having fun.
Yeah, no, yeah, in my dreams. Actually, I wanted to be part of this beta program because I wanted to, from a technology perspective, learn all I can about it, to learn what our competition may be. Got it installed here 2 days ago, and this is in Walla Walla, and got it up on the top of the house, and did some speed tests on it. It's about anywhere from 30 to 50 megabits in our region. The one thing that I'm seeing, though, is the latency is a little bit high. There's a speed test with what they call loaded and unloaded latency. The loaded latency is actually up in the 400s.
Wow.
And the unloaded latency is not bad at 32. So it is still very much in beta, and they tell you it's better than nothing. That's what the program is called. And I think for some connectivity that for people in really rural areas, I think it's going to be good. They're launching a lot of satellites, and it's one we're watching it pretty closely here. So, and I'm watching it directly as well. Anyway, not sure if that answers your question.
I can add to that real quick too, and we were talking about this the other day, and that's just the emergence of satellite technology in general. We're seeing tons of small sites, low orbital. There's a dozen different IoT companies launching stuff. So there's the higher bitrate stuff like Starlink. You got AWS is going to have Project Jupiter and all that stuff pretty soon. Just looking for launch vehicles. But if you track IoT and satellite connectivity for these really, really remote locations, where what we say is you have 0G out there. I see for someone like Andrew, it might need some bandwidth at a certain location. It might be perfect for that. But we had a conversation yesterday around direct to sensor. There's a multitude of startups. You have Lacuna Space, you have Kepler, you have Fleet Space, you have Hyber, and you might have heard of Swarm Space. So these are specific companies that are building just radios specifically. Maybe they're using LoRaWAN modulation actually, but to direct to sensor. So it's not necessarily a broadband access, but it's flipped to the other side. That it's going to be interesting as more and more launches with these small little tiny CubeSats to see what options are coming in the next couple of years.
Yeah, and that's a good tee up for Andrew, where an anonymous at 10 how you get internet service to your house in Farmington, and maybe you tie in a little bit on your thoughts on Starlink as well.
Yeah, so I think that Starlink will be a great way to get connectivity to somebody who doesn't have it. My hope is that you could be able to move where you're using Starlink, because then I could have that at different sets of bins and stuff like that. I do some AI identification on my trucks, for example, and that would be great to have that there. But the latency worries me, and also if they are adding so many people to it, I'm concerned about overall capacity on it. And then my last concern was tweeted out a few days ago. Elon Musk says he hopes that he makes the first satellite internet low orbit that doesn't go out of business. So that when I read that, I was like, oh, that's, you know, instills a bunch of confidence.
So that day.
So those are kind of my concerns about. I'm very excited. I'd love to mount one on my tractor or combine, or better yet, bring it along with me in my pickup. So that way, wherever I'm at, if I'm in a low spot or whatever, I could at least have some connectivity. I think that fiber will always beat it out. What I have right now on my farm, I work closely with somebody like Todd. He's a wireless internet service provider in our area. It's Y-Fiber is what he calls his company. And so I'm able to get access. It's very low latency. And they are working to increase bandwidth. That's one part that isn't quite as good right now as overall speed. It's good for my area. I do get during the day, I'll be in the 20s, usually low 20s, but they are working to increase that substantially, I know. So yeah, get to know your local wide area or wireless internet service providers well.
Well, great conversation all the way around. Clearly, there is a place for each of these technologies, and I think that's really the takeaway, right? Is Starlink, as an example, is not going to be something that you're directly connecting an IoT device, and I think to Scott's earlier point with LoRaWAN, you can go, because it's so efficient, power-wise, these things are basically can remain untouched and undisturbed for 5 years plus, and keep on going. So it's all about the coexistence, we think, of Starlink, fiber. Ultimately, fiber, that is the best of everything, assuming you can actually get it. The joke I have back and forth with Andrew, he says, yeah, hey, I'm getting fiber anytime. Well, he's been saying that for a while, but it's coming. It is coming.
I'm getting fiber, Steve. Steve, it's coming.
It's coming.
He's got fiber in his diet.
I have a building out here for the fiber to come in now. So waiting on the wire.
So there's another question here in the chat.
Yeah.
Look, did you see that as well?
Yeah, from Dave Brown. And Scott looks like he spoke to it briefly.
Oh, there's one on 5G, and it sounds like radiation.
There is. I'm not seeing the one on 5G and radiation.
I don't see that one. It
says, are you concerned about 5G possibly adding excess radiation to produce?
Got it. So does anybody want to take that?
Well, I think it depends on the type of 5G. 5G is kind of a buzzword out there right now. If you're talking about 5G for cellular, a lot of those are the cell sites are very small. In other words, what we call a microsite, and they only go about 2,000 feet thereabout. And so traditionally, a lot of the 4G towers, the cell antennas are very high up on the tower, but with 5G, they're going street level, poles, that type of thing. Now, if you had a 5G service in the field, I doubt that it would be very close to the produce, to cause much radiation. Cellular does use a lot of power to transmit that data. It's a matter of physics. You have to have power in the spectrum, or the wavelength. On the technology that we use is actually a much lower power than any of the cell carriers use, because it's actually point to point, or what we call point to multipoint. So I can't address the cellular point about it, but maybe that helps just a little bit.
Yeah, and I think, I mean, it's certainly something, if you'd like to delve in more, we can bring in experts to speak to you about that. Certainly a legitimate concern, but it all comes down to what Todd was saying about how strong the power transmission is. And it's just like, well, do you worry about Wi-Fi in your home and it radiating your apples or your fruit in your home? Well, not really. And so it's designed to not be strong enough to radiate further than a certain distance. And the same thing applies to whether it's TV white space or whether it's different cellular technologies, including 5G. I think one last thing I'd like to add as we close, 5G is it's a bit of a loose term, as with any of these 3G, 4G. There's a lot of marketing to it as well. But I think a key thing to call out is edge computing is often considered kind of fitting underneath that umbrella as well. And it's really, I believe, a game changer on being able to process some of that data closer to the farm without having to go all the way up through a link. And that's just kind of one more thing to consider in this. So look, as we close, really want to encourage you to reach out to any of us. I'm happy, if you didn't catch contact info for Andrew, Scott, or Todd, I'm happy to connect you to any of them. Ultimately, our focus as Innovate is we want to help growers better be able to tie data together. And there's such a reliance, of course, on the data, on the network, and that's why we're doing this. Do join us in a couple of weeks. It'll be a much more open forum. This is where you can poke fun at Andrew for not having his fiber in yet, or I don't know, what can we make fun of you for, Todd?
You not having your Starlink up yet.
That's
right. Steve still will not have Starlink up. I will most likely go and steal it from him and put it up at my own house.
All right. All right. Listen, thanks so much, everybody, and really appreciate your time. Have a great evening, and stay warm if you're here in Eastern Washington where it's cooling down.